everybody is taking notes. You're responsible for the test, okay? Don't say, but I didn't understand. See you right back. Come on, you're on. Go ahead.
Okay, so cardioids are, the name cardioid came from the heart shape of the curve.
1 second, I'm sorry. The group that just finished, I need your package with your 4 names. Okay? Sometime before you leave today.
Okay. The name cardioid comes from the heart shape of it, because it does make a heart shape, just like the symbol on there. And it's Greek in origin, but in real life you can see cardioids like this, like when you have a round cup and that's partially filled with liquid, the way the light hits it, that's a cardioid on there. You can see the, if you can see the point. Yeah. That's a cardioid. That's also a cardioid.
Whoa. No, see the shadow? It's like a shadow.
Yeah. And then there are some, like we started learning about the complex plane and how things are graphed on it. This is on the complex plane. It's called the Mandelbrot bulb. It's just really cool looking, and that's a cardioid in the middle. Yeah. And that's another piece of it. It's just a repetition using the cardioids and other shapes. And then they use cardioids in microphones as well to help pick up for certain types of sounds. Yes, that's a cardioid microphone. Okay, now to graph the cardioids.
Just stand next to it. This is right on top. Okay.
Okay, so cardioids.
First of all, the equation on the right hand side.
So I'm going to graph -2 minus 2 sine theta. All cardioids are using.
Write the equation. Why are you people not putting the R in front of it?
Okay, all cardioids are R equals A plus A cosine theta, or A plus A sine theta.
So the requirement is that
These two numbers have to be the same.
if it's 2, it's 2. If it's -2 is -2. It has to be A. That's why it's A instead of A and A.
Yeah. So if you see the two numbers are the same, including the negative signs, then it's a cardioid. And cardioids are all shaped like so, like a heart. There's no point though. And then if there's a negative in front, if A is negative, all that it affects is the direction that the cardioid goes in. So sine cardioids.
I have a question.
Yeah.
Is she presenting everything?
No, I'm just the overview, and then we're
You
doing
are splitting up the presentation.
Yeah.
Right?
We have to
I just want to give 16 points and you guys 0.
No. Sine cardioids go up and down. So this and this, they're both sine cardioids.
Sketch it on your paper. Keep it straight.
And then
What sign above it is?
this is a positive sign, and this is a negative sign. Like if A is negative and it's a sign, it's going to be this shape. And if A is positive and it's a sign, it's going to be this
put
shape.
it underneath.
Yeah, right, positive.
Sure it in it.
Yeah, I
A
wrote it in
equals
the
positive.
sign.
Put A, don't put positive, negative in front of the sign. Put A equals positive.
A equals positive. And then for cosine, it goes this way and this way. And then this one is when A is positive, and this one is for when A is negative.
Good.
So the way that the negative only affects the direction of it. So when we start graphing and we're talking about A distance, we're talking about just the number, where the negative only applies to the direction that the graph goes in. So when we're graphing cardioids, they're all with this. They don't have, like some Lewisones have a circle in here. They don't have that.
Yeah, they don't have it in the loop. Okay.
And they all start at 0, 0. That's always the first point for a cardioid. No matter what, it's always 0, 0. So for this one that we're graphing now, -2 minus 2 sine theta, because A is negative in its sign, it's going to make a shape like so. It's not that badly looked.
Can you use a different color?
Okay.
Thank you.
Well, I'm going to be using a lot of colors. There's diagrams. Okay.
Well, let us stay with black since she's graphing the black equation. She will graph the equation, okay?
Okay. So when we're talking about graphing it, we start with 0, 0, and then A is 2 in this case, because we already dealt with the negative saying that it's going to be in this kind of a shape. So A is 2, so we're going to go to the right and left 2, because this distance here is always A. Okay? And then when we have to go down because this is 0, 0 always. And because it's a negative sign, we're making more distance down here. And this is going to be 2A in distance. So 1, 2, 3, 4. And this distance is 2A. And it's always like that. Remember, we're disregarding the negative at this point because we already said it's going in this direction. So this is A each this direction and 2A this direction. And then because this is a sine always deals with 30 degrees and negative 30 degrees because sine of 30 is 1/2. And when we're dealing with cosine, it always deals with 60 degrees and negative 60 degrees because cosine of 60 is 1/2. So we're dealing with this line across here and this line across here. So in order to get this point here, because we want to make a heart shape, yeah?
Can you just repeat that again about if it's cosine?
When we're dealing with sine cardioids, it's always with the 30 and negative 30.
Just deal with sine. Cosine out.
Okay. It's always dealing with 30 and negative 30. And so we have these two lines, and we're trying to find out what these 2 points are now. So you go over half A, which in this case is 1, and you go up until you reach the 30 line. And then same with the other side. You go over half A and up until you reach the 30 line, or negative 30, depending on which side you're on. So now we have 1, 2, 3, 4, 5, 6 points. We need 2 more to get these sides, how wide it is. And so this distance is always half A. And then the last distance we're using is 3/2 A. We go from this origin, we always start at the center, we go 3/2 A out down the 30 and negative 30 lines. So 3/2 times 2 is 3. So we're going to go 1, 2, 3. This distance is 3/2. 1, 2, 3. This distance is 3/2 A. And then we just connect all the points.
Nice job. Okay, next person take over.
Laura's going next. Who's going here?
Laura.
Yeah.
Those start with black. Oh, you're going to this. Okay, that's fine. You go to a different place.
Okay, so now we're going to do the positive of
A
sine.
equals positive 2. Everybody's on? Okay.
So basically, like Carolyn's graph, the only thing that's going to be changed is the way it's facing. So instead of going down, it's going to face up. And again, we always start at 0. Next, you graph the way it's going. So go 2 out, which is A.
Good.
You can go 1/2 A on both sides and down to the 30 lines again. So you already have half the graph. Then you do the 2A going up. So because A is 2, so if you go up 4, 1, 2.